the first question will be asking us to calculate the variance and standard deviation for ungrouped data. As we have said, that we are supposed to find the variance for ungrouped data. So the first question, to use the following data which show the age of the student at Kilaweni Secondary School and answer the question that to follow. So you have given the question over there, you have been asked to find or to determine the variance. But on B, you have been asked to calculate the standard deviation. So this is the sample of the questions for ungrouped data. But again, we have question number 2. For question number 2, as I said, we have the grouped data. So we have the classes, we have the frequencies. And then we'll be asked to find the what? The variance and the standard deviation. But again, we've been asked to explain the advantages and disadvantages of the standard deviation. So we try to solve it. And the third one, which will be the last one, as I said, we have been given the questions with so many data over there. As they are saying, those are the data that have been taken from Katora Secondary School, specifically for the geography student scores. And we have been asked to find the what? The variance, but again to calculate the what? The standard deviation. And we have been asked to explain the importance of calculating the standard deviation. So if we check that question, it is quite different from the second one. The difference is, over there we have to develop the what? The table of frequency. But for question number 2, we had the table of frequency already developed, and then we started to compute the variance and the standard deviations. So those will be the guiding model questions for our revision. Before we go for the revision, I would like to remind you about the following. You can just recall on the so-called, we're talking about the data, because the center of our revision is centered on the so-called what? We're talking about the measure of dispersion. So we have the mean somewhere. Let's say this is the mean. So the key function of the variance and the standard deviation is just to show how the data are spread, either approaching to the mean. So we are assessing how are they spreading along the data set. That's the intention. So we should have a revision about the data. So for the data, I think remember we have the so-called ungrouped data. Ungrouped data. But again, we have grouped data. As we have seen for the question number 1, which we'll be solving soon, for ungrouped data. But again, we are being asked to find the what? The variance and standard deviation. Those are the center of our questions. We're talking about the measure which shows how the data have been distributed along the mean. So I just want to have a general revision which will guide us so that we can be able to proceed with our revision. In order to find the variance and the standard deviations, we need to recall on the so-called the mean. As I said, we should be able to recall on the what? On the mean. So for the mean, I think we all know that the mean for ungrouped data is given by is equal to the summation of x over n. This is for ungrouped data. Then you get the mean, which is very important for the computation of the variance and the standard deviation. When you go for the grouped data, the mean is given by the summation of f x, then you divide by n. Then you get the mean. Then again, because we're talking about the variance, the variance for ungrouped data, I think remember to recall, it's given by is equal to the summation of x minus x squared, then divided by n. But again, the variance for the grouped data is given by this is for the grouped data. variance for group data is equal to the summation of f x minus x bar squared, then you divide by n. Then you get the variance for the group data. But again, when you go for the standard deviation, the standard deviation, nothing else, rather it's about the under root of the variance. So if you take the under root of the variance, that is the summation of x minus x bar squared, then you divide by n, we get the standard deviation for ungrouped data. But then we find the standard deviation for grouped data. The standard deviation for grouped data is given by the under root of the variance. Then it will be equal to the under root of the summation of f x minus x bar squared, then you divide by n. So it's very important to revise those things, because those questions that we are going to try to solve or to revise, they will be centered on those things. I know it's a part of the parcel of the revision, so I don't need to go in detail about those things. You are aware about those things. Let's go to the first question. Question number 1 is for ungrouped data. And we know that we have been given the data that use the following data, which show the age of the students at Kilawini Secondary School, to answer the questions that follow. So we have 15, 8, 7, 6, 12, 5, 14, and 13. Then we have been asked to determine the variance, and we have been asked to calculate the standard deviations. So already we have our formula over there. And remember we said question number 1 is just for ungrouped data. So if it's ungrouped data, we should go through the following procedures. The first one, I think you are aware about the table. We should develop the table over there, because the data that was given over there is we start with x, and for x we have 6, we have 5, then we have 6, then we have 7, we have 8, 12, we have 13, we have 14, and we have 15. 1, 2, 3, 4, 5, 6, 7, 8. It's okay. So this is the first column, just for x. But then the next column should be for it's about the mean, x bar. And then we should develop another column for bracket x minus x bar. And again, we should have another column for x minus x bar squared. So if you check on your data, because we said those are the ungrouped data. Ungrouped data. So if it's ungrouped data, as we said, the first procedure should be the computation of the so-called the mean. So if we want to find the mean for the data that we have over there, the mean for the ungrouped data is given by the summation of x over n. So over there we have to sum up the summation of x. We have said that is 8 over 8. Then you get 10. So 10, that is our mean. And then we have deducted the mean from each x. So the next aspect, we go to the last column, which is all about bracket x minus x bar squared. So we are much interested with the summation of x minus x bar squared. That's our interest for that particular column. And then we divide by n. N will be counting the number of what? The number of x that we have over there. So what we do, we just find the summation of that particular column. So we start with 25 plus 16 plus 9 plus 4 plus 4 plus 9 plus 16 plus 25. Then we come up with a total of it's 108. That's the total for that particular column. Then we can recall, we just recall the just recall on the formula for finding the variance. So it will be the variance is equal to the summation of x minus x bar squared, then you divide by n. So for our case, we will take 108, then we divide it by 8. So if we divide by 8, it's 108, we divide it by 8, then we come up with, the answer will be 13.5. So this is the variance for that particular question. This is the variance. But again, if we call on the second aspect, that's about the standard deviation. The standard deviation, as we said, it is given by underrooting the variance. So if we underroot the variance, so it's equal to the under root of the summation of x minus x bar squared, then we divide by n. So already we have a 13.5. So if we take 13.5, then we underroot it, we come up with the standard deviation. So we underroot it, then we come up with the standard deviation of 3.6742. So for our questions, that will be the end for the solving. If we call it, then you can cross-check. It means the standard deviation from the mean, where we have the mean of 10, the standard deviation was 3.6742, and the variance is 13.5. For question number 2, it's a little bit complicated because over there we have to find the class mark, then we should proceed with the other things. So question number 2 is given as carefully study the provided data and answer the question that follow. We have been given the classes, given the frequencies. Then we have been asked to find the what? The variance, the standard deviation. So as usual, we should develop that table. We have the table for class. So we should develop the table of frequency. And for the table of frequency, as we have been given there, we have the first part which compose the classes, but then we'll be given the frequency. So the first one, that is 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, 45 to 49, 50 to 54, 55 to 59. Those are the data which was been given over there. So over there, we are supposed, and we have given the frequency. The first one, that is 3, then 7, then 8, then 12, then you have 9, then you have 6, 4, and the last one is 1. So over there, we should establish another column. As we have said, that you cannot compute the variance or the standard deviation if at all we don't have the mean. And remember, this is the group data. So for the mean, we should establish something that is known as the class mark. Class mark. We should establish another column over there, special for the class mark. And when we say the class mark, I think remember, this is given by taking the lower limit, then you plus the upper limit, then you divide by 2. Then you get the class mark. So we'll be doing the same for that one. So for the first column, that is the 20, the lower limit, the upper limit is 24. So we take 24 we'll be taking 20 plus 24, then we divide by 2. So for the first class mark, we'll be having 22. And because the class interval over there is 5, so it will be 22 plus 5, then we get 27. Then plus 5, we get 32. Again, plus 5, we get 37. Then we get 42. Then 47. Then 52. Then 57. So this is the class mark. This is the class mark, which will be standing for X. You can say this is X. Then we have another column that was supposed to establish over there so that we can be able to find the what? The mean. So we have F times X. That's another column we should establish over there. And for that case, it means we'll take 3 times 22, then we get 66. 66. Then we go for the next one, that is 7 times 27, then we come up with 189. 32 times 8, come up with 256. The other one is 12 times 37, then we get 444. Then we have 9 times 42, then we come up with 378. The other one is 6 times 47, then we get 282. And then we go for 4 times 52 is equal to 208. And the last one will be 57. So this is fx because we just want to compute the so-called what? The mean. We want to compute the mean for the grouped data. Therefore, we have said the mean is equal to, the mean for grouped data is equal to summation of fx, then you divide by n. So for that case, we should sum up that column. If you sum up that column, at the end of the day, you come up with a total of 66 plus 189 plus 256 plus 444 plus 378 plus 282 plus 208 plus 57. Then the answer is equal to 1880. Then we divide by n, and the n for our case is the summation of that particular what? Summation of the frequency. And if you sum up the frequency, you come up with 50. So the mean for our case will be equal to, then we divide by 50, and then we get 37.6. So 37.6, this is our mean. So already we have the mean for the grouped data, which we have obtained there for the question number 2. Then we go for we establish another column that will be x, and then we have fx. Then we have another column for that will be the bracket x minus x mean and squared. Then we have another column for f bracket x minus x mean squared. So we should have another column for that one. So from our data, we'll take the class mark that we have obtained over there. So we have 22, then we have 27, then we have 32, then we have 37, then we have 42, you have 47, then you have 52, then you have 57. Then fx, we had it, it's about 66, then you have 189, then we have 256, then we have 444, then we have 378, and then we have 282, then we have 208, and lastly we have 57. So we go for that particular column, and of that particular column we should find, I think you have the calculator, you just take the x, just to bracket, then 22 for the first case, minus the mean. We have the mean over there, that is 37.60, bracket, then we square, and then we get, for the first part, we get 243.36. Then if you go for the next one, you'll be doing the same. Then you come up with 112.36. If you go for the next column, you come up with 31.36. The other column, you'll come up with 0.36. The next one, you come up with 19.36. The other one, it will be 88.36. The other one will be 207.36. And the last one, 376.36. But we are much targeting to the last column, which is about the summation of f times x minus bar. So this one times the frequency. You remember the frequency that we had over there. So we should have another column for the frequency. And for the first aspect we had 3, then we had 7, then we had 8, and then we had 12, but again we have 9, and we had 6, we have 4, and lastly we have 1. So we take that one times frequency, then you get that particular column. So for the first part we take 243.36 times 3, then you come up with 730.08. The next one, take a form and this one, and then you come up with 786.52. Again, when you go to the next one, that is 31.36 times 8, then you come up with 250.88. The next one, you'll come up with 4.32. The next one, you'll come up with 174.24. The fourth one, it is 530.14. And the last one, it will be 376.36. Then if you call on the formula, we are now talking about that particular column. It's about the summation of fx minus x bar. If you sum up that particular column, you will come up with 3682, then you divide by 50. Then I will get 50. You remember what we did here. We are still talking about the frequencies. So if you divide by 50, your answer will be, or the variance will be equal to 73.64. The variance. But you remember we said if you underroot the variance, then we get the standard deviation. So what we do over there, we want to get the standard deviation. So it's equal to the under root of 73.64. So if you take your calculator and then under root 73.64 to give you 8.5813. So this is the standard deviation. So the standard deviation, that's what we have scored over there. Then the variance is 73.6. So that's how you can solve about question number 2, which is you have been given the data, which is already in table of frequency. Then you are supposed to do what? To find the variance plus the standard deviation. Okay, dear student, let's proceed with our revision. We can just recall on the first question that we have done. It's about grouped data. Then the second question was about grouped data, but it's quite different from the third question. For the third question, the way it is, it's about carefully study the following data on the student's score in geography subject at Katola Secondary School and answer the question that follow. This question, it's also grouped data, but it's quite different from the second one, because the second one already we were given the table of frequency. But for that particular question, we have been given the data according to the score in geography, so they are not grouped. And remember, the function of statistics is about summarizing the data. So we have the task of developing or establishing the table of frequency so that we can solve that particular questions. So before we start solving that particular questions, we should recall about we should check the data on how many students scored the lowest score and how many students scored the highest score. So if you check on those data, you'll find that the lowest score is 24 and then the highest score is 78. So what we are supposed to do over there, we should establish the classes. We should establish the table of frequency so that we can solve that particular question. So let's come to that particular table. We have established the classes over there. So we have the class which is starting from 24 to 33. But again, we have the class which is starting from 34 to 43. Then the next one, 44 to 53. 54 to 63. 64 to 73. Then 74 to 83. Then you check over there, we have accommodated the range of those data that we have over there. So what do we do before we start solving anything? We just recall about it's about the grouped data. The grouped data. Just recall the formula for finding the mean for grouped data. We said is equal to the summation of fx, then you divide by n. And then over there we'll be having the mean, because remember we have established the column over there. The first column is just for f, the frequency, then we have x, then we have fx, then we have brackets x minus x bar squared, then the last one will be the frequency times the bracket x minus the mean squared. Then you get another column, so that we can be able to come up with the summation of fx, then you divide by n, then you have the what? The mean. Again, we are talking about the what? The variance plus the standard deviation. So over here, we'll be talking about the summation. That's about the variance. It's given by the summation of fx minus x bar squared. Then you divide by n. But again, the question is asking us to find the standard deviation. So the standard deviation. And the standard deviation is all about is equal to the under root of the variance. So the under root of the variance will be the summation of f bracket x minus x bar squared, then you divide by n. So it's very simple, because we have that column where we have to find the what? The mean, which is the first thing. But again, we have the last column which we are supposed to find the what? The summation of fx bracket x minus x bar squared. So what we do over there, we just start to do what? To cross-check the second column, which is about the frequencies. So we are assessing the students who scored from 24 to 33. The student who scored from 24 to 33 according to the data that we have been given over there on question number 3. So if we check well, the student who have scored along that particular range, you'll find that we have the first one, that is 24, then we have 28, then you go to 32, then you go to the 54, and then you find the next one is 33. So those students who've scored between 24 to 33, they are just 4. So we put 4 for the frequency. Then we go for the next column. That's about the students who have scored from 34 to 43. The students who have scored from 34 to 43, if you check, just turn back to our data, 33, 34, it's about 34 to 33. That's one. You go on that particular data, you check, you have 30, you have the next one, then the other one, the next one, next one. So for that particular column, we find that we have 8 students. So there are 8 students who scored from 34 to 43. Again, we go to the next class. That is from 44 to 53. 44 to 53. 44 to 53. This is number 1, 2, 3, 4, 5, 6, 7, 8. So they're about 13. So we have 13 students who scored from 44 to 53. Then you go for the next class, that is 54 to 63. 54 to 63. We also check there. Check the number. If of course check them, when you check them, you will find that along that particular class we have 14. So we have 14 students who scored 54 to 63. Then the next class is 64 to 73. If you check on that data, you will find that 64 to 34, you will find you have the following data. 63, you will find that it's about 64 to 70. If you check on the data there, you will find that we have 3 of them. So 3, they have scored 64 to 73. And then you go to the last class, that is 74 to 83. If you check on the data that we have been given, we have, it's only 1. So we have 78. So we have 1. But again, you should cross-check the summation of F at all there. You check the summation of F. Then you take 4 plus 8 plus 13 plus 14 plus 3 plus 1. Then you come up with a total of 43. So you should check if at all you have 43 based on the question. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 14, 15, 13, 15, 13, 14, 16, up to the end. Then you come up with a total of 43. So there are 43. So we have 43 at the frequencies. If you not get 43 according to the number of students in the class, it means there is a problem somewhere. But because we have 43 students and we have their score, therefore we say we are correct for that particular column. Then you go for the next column, that's about X. Then for X, I think you know, here we are talking about the class mark. This is the class mark. So for the class mark, I think, remember, as we did for the second question, it's about the lower limit. Lower limit, we plus the upper limit, and then we divide by 2. So for that particular questions, we have that particular classes. So we take 24. We take 24 plus 33, then we divide by 2. Then you get the first class mark. So we take 24 plus 33 is equal to, we divide by 2, then we get 28.5. So because we have the class size of 10, then we just add for the next class. So here we'll be getting 38.5. This will be 48.5. This will be 58.5. Here we get 68.5. And here we get 78.5. So already we have the data for the class mark. Then you go for the next column, which is all about F times X. So we take the class mark times the frequency. Then we fill that particular column. So what we do over there, you take 4 times 228.5, then we come up with 114. It's 114. Then you go for the next one, that is 8 times 38.5, then you come up with 308. Then you go for the next column, that is 13 times 48.5, then you come up with 630.5. Then you go for the next column, that is 14 times 58.5, then you come up with 819. Then you go for the next one, that is 3 times 68.5, then you come up with 205.5. And the last one, 1 times this one, we get 78.5. So we have done with the fx column, and when we are done with the ff column, we should recall that we are supposed to find the what? The mean. So how do we find the mean for that particular column? We have given the formula over there. It's about the summation of fx, then we divide by n. So for that case, we have to find the total of that particular column. And if you find the total of that particular column, you come up with the following. It means you take 1, 4, it's 1, the 4, then we plus 308, we plus 630.5, we plus 1819, we plus 205.5 plus 78.5. Then we come up with a total of 2155.5. So the total, so the mean for that particular case will be 2155.5. Then we divide by the number, that is n, we divide by 43. So if we divide by 43, we'll come up with 50.1279. So this is our mean. So already we have the mean for the class. So the mean for the score, or for the geography scores was, or it was supposed to be what? 50.1279. So from there we go to the next column, because we should fill that column. And that column is about bracket x minus the mean, then square. So what we do over there, we'll be dealing with that column. The column for the class mark, we have it here. Then we minus the mean, because we have the mean, it's already there. And then we square it. So we start with the first column. That will be x, that is 28. We start with the bracket, then 28.5 minus the mean. The mean is the 50.1279 bracket, then we square. Then for the first column, here we get 467.760. We try our best to be able to take the decimal points of 4 decimal points so that we can be accurate. Then we go for the next column. It's about brackets. So we take the brackets, that is 38.5. We minus the mean, that is 50.1279 bracket square. Then we come up with it's 135.2080. Then we go for the next column, bracket 48.5 minus 50, that's our mean, 1279 bracket square. Then we come up with 2.6500. Then we go for the next column, that is bracket. So we take 58.5 minus the mean, that is the 50.1279 7.1279 bracket square, then we come up with 7.092, and then we go for the next column, that is 68 bracket 68.5 minus 50.1279 bracket square, then we get 307.3540. And then for the last one, we take the bracket, that is 78.5 minus the mean, that is 50.1279 bracket square, then we come up with 804.9760. So for that particular column, there's no summation that we're supposed to do. So what we do for that particular column, we are much interested with the next column, which is F times that particular group. So we take that F times that one. So the first column will take 4 times that one. So we take 4 times 467.7660. Then we come up with 1071.064. Then we go for the next column. That one will be 8 times that one, 135.208. Then we come up with 1081.664. Then we go for the next one, that is 13 times 2.6500. Then we come up with the 34.45. The next one, that is 14 times 7.092. Then we get 981.288. Then you go for the next column. The next column is 3 times 337.3540. Then you come up with 1012.062. And for the last one, I think it's 1 times that one. So it will be 804.9760. So once we have that column, the next issue is about the summation. So we have to sum up that column. And if we go for the summation of that column, what we do, we take 1871.064, then we plus 1081.664 plus 34.45 plus 981.288, then we plus 1012.062 plus 804.9760. Then we come up with the total of it will be 575.9 504. So this is the summation of f x minus x bar squared. And when you turn back to the formula on how to compute the variance, we said the variance is equal to summation of x minus x bar squared, then you divide by n. So for that case, we'll take that number, then we divide by n. N is 43. So the variance is equal to 134.5466. That's the variance. Then we go for the standard deviation. The standard deviation, we say the standard deviation is given by, we just hand out the variance. Then we hand out the summation of f bracket x minus x bar squared, then we divide by n. So for that case, our standard deviation will be, we just hand out that one. Then the answer will be 11.59994. So this is the standard deviation for our question over there. But then we should recall about the interpretations. What the meaning of that particular answer? The meaning of that particular answer means if you just sketch your graph, then you say this is your mean according to the data that we had. That's the 43. This is the mean. Then if cross-check it, it means the way those data they have been distributed, they have disparted from the mean for about 11.5, and then this is too high. So have higher standard deviations. And as we said that if you have higher standard deviation, it means that the data have disparted away from the what? From the mean. But if it is small, it means the concentration is along the mean. So for that particular question, that's how we can solve it. But I just want to caution you students, when you are doing those questions, make sure that you note down those tables and make sure that you are competent on the use of the calculator, because that particular question is time consuming. Time consuming. So how do you solve it? You make sure that you are competent, just competent with the use of calculator, but again, time management. When you start that question, make sure that you don't each and everything. But you solve it if at all you have the accurate in terms of that particular table. Classes, frequency, x, then you find the fx, then you go for the bracket x minus bar squared, and the last one, because you are hunting the summation of f bracket x minus x bar squared. So that's the end of that particular question. On the aspect of advantages, they are saying is the best measure of dispersion. Among all the measure of dispersions, including the mean deviations, the best one is the standard deviation. Why are we saying the best measure? Because it gives you clear the picture to what extent the data have deviated from the what? From the mean. So if we have the standard deviation, it means we know how much have you deviated from the mean. But again, they are saying it cannot, or it is less affected by sample fluctuation. Sample fluctuation. That being the case, it is being used for the hypothesis testing because it is free from the sample fluctuations. It maintains its status. It is stable. It's quite different from the other measure of dispersion. But again, they are saying it is mostly applied for statistical analysis. Very important. It's very important in statistical analysis. The last one, the smaller the deviations within the series, will be easier to make a comparison with the other variables. That it is the best. It is the best for comparison. Remember, you can compute the mean deviation for two samples, and then you can compare them. So we say it's the best measure for comparison. You can have two units, then you compare them. But again, those are not the only issues. We have the disadvantages. So we go to the last aspect, which is about assessing or explaining the disadvantages of the standard deviation. The standard deviation we have seen, we have appreciated it, but again, on the other side, it has got the following challenges or the following disadvantages. The first one, we say it's a very complex method because we have seen it's very difficult to compute it. But again, what they are saying, it's mostly affected by the extreme values in the series. If you have so many values, it will be affected. It cannot provide you with the proper answer. But again, the last one, it cannot be used for comparison, especially when you are comparing two things that has been given different units. But again, the last aspect that we should appreciate is about the importance of standard deviation. Generally, the importance of the standard deviations is very simple. Standard deviations, it's very important because it assists us to know how the data have spread the data set. If you have the data, you'll be able to know how those data have spread out. For instance, you can just use that particular diagram. You can recall about what's happening over there. That's the conclusion of that particular part. So if you have low standard deviations, it means your data are approaching to the what? To the mean. Take an example of the red one. The red one, it has got the standard deviation of 0.5. Therefore, you see all the data, they are closer to the mean, which is 2. The mean is 2, then the standard deviation is what? 0.5. But when you come up to the standard deviation, when it is 2, when the standard deviation is large, it means the data has been what? Spread out. That's what we see over there. The mean, the standard deviation is just 2. But you can see what's happening. It means the data they are distributed, cutting across the series. So the intention of having the standard deviations, we just want to try our best level to squeeze all the data so that they can be near to the what? Near to the mean. That's the essence of standard deviation. So if you compute and then you come up with a high standard deviation, it means your data would be staggered or would be spreading out. But if they are closer, you have a small standard deviation, it means your data, they are closing to the mean. If you want to make further reference about what we have been doing, you can just refer the following text. I think they are written over there. We have the Chandia textbook of probability. It's very important. But again, you have the book of Kothari, research methodology, give you ABCD connected with standard deviations. But again, we have the book of Pritchard. You can get ABCD connected with standard deviations. But again, you have the book that has recently provided by the Tanzania Institute of Education, that is Basic Applied Mathematics for Advanced Level, book 5 and 6. It can assist you to compute or to revise about those areas. So dear students, thank you for listening. Have a nice time.
Kipindi cha Darasa Online kimeletwa kwenu na Chuo Kikuu cha Sauti Mbeya.